Okay, let's get started here on polar day 3. For this one, we're going to be talking about area with these polar coordinates, but this time we're doing area in between two polar curves, which can get a little tricky. It really is dependent on your ability to go ahead and graph these things. So let's get rocking and rolling here. So we got two problems. Sketch and set up the integral. So this is setup only, which is nice. Integral expression to find the area inside the graph. We have two of them. We have r equals 3 sine, which is going to be just a circle, and outside the graph of r minus sine of theta. Do not evaluate. Okay, so I'm going to go ahead and sketch these guys. So this first one in green. Okay, in case you don't know how to sketch it, I will go ahead and show you how I would sketch the green one right here. Okay, so this is just a basic sine graph with an amplitude of 3. So go out here to 2 pi. Here's pi over 2, 3 pi over 2, and you're going to start here, 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 and here. Okay, so at 0, we're at 0. At pi over 2, we are at 3. 1, 2, 3. At pi, we're at 0, and at 3 pi over 2, we're at -3. So we're back over here. So what this is actually telling me is from 0 to 2 pi, it's going to repeat itself. So essentially what's going to happen here is I'm going to sketch this, and if you notice, it's going to, because it's negative after pi, that's in this part right here. Because it's negative in pi, I'm not sketching it down here, I'm actually sketching it up here, and it's the same shape. So this is going to end up being a circle here. Now when I sketch these, especially with the intersection ones, I'm going to sketch this to be a little bit fatter than I usually would, because I want to see if there's any little extra pieces I need to catch on these. So I'm going to go ahead and sketch this out right here. All right, so here's the circle. I'm making it a little bit fatter than I usually would, because I just want to be extra careful, see if I can catch anything that I need to with my graph. That's actually not too bad. And then let's go ahead and sketch the blue. That's 2 minus sign. So I'm going to start up here at 2, and actually amplitude is just 1. So I'm going to go down to 1, up to 3. Same thing, I'm going to go all the way out to 2 pi. Pi over 2, 3 pi over 2. If I sinusoidal axis, just for a reference, makes it a little bit easier. So this is what I'm going to look like here when I'm sketching this. So it's going to look something like this. All right, so at 0, I'm at 2. At pi over 2, I'm at 1. At pi, I'm at 2 again. And at 3 pi over 2, I'm at 3. So this is going to look something like this. Kind of, sort of like a circle here. Maybe like a more, I don't know. Not really. And there we go. Well, that's good enough. Right? Okay, so here's my two graphs. And again, you can kind of match it up. Like a little bit after pi, it gets longer, so that's why I'm going out a little bit more, jutting out a little bit more. So this wants me to go inside of green, outside of blue. That's just gonna be this yellow part right here, right? So inside of green, outside of blue. So I need this right here. Okay, so what's gonna end up happening here is I have to integrate this from this point to this point. Okay, so from this little line right here all the way over here. And what I'm doing is I'm integrating green, because I need to count for green, but I also need to take away the blue to give me the yellow area. Okay, so kind of the same idea we done before with big minus little. This one straight up just tells us we got to do green first. So it's going to be green, get rid of the blue in this area. There's no weird intersections here. I'll come across that the next example, so don't have to worry about that too much. What I do need to find is these intersections right here. So how do you find these intersections? That's right. You set the two radii equal to each other and figure out when the theta is equal. So let's go ahead and do that. So I'm going to do 3 sine theta equals 2 minus sine theta. I'm going to add that sine theta over. So we're going to get 4 sine theta equals 2. Not 2, equals negative sine theta, because I moved that 2 over. Wait, no, I was right. It's early in the morning. Equals 2. And then to get sine by itself, divide by 4. So I'm going to get, divide that by 4, divide by that. 4 by 4, sine of theta equals 1/2. When does sine equal 1/2? In 2 locations here. You can see first and second quadrant matches up because sine is positive in first and second quadrant. This is going to happen at pi over 6 and 5 pi over 6. So you got to be sharp on those values here. Okay. And then a quick little friendly reminder for what my area formula is. For polars, it's 1/2 from, I forgot if they used, I think they used alpha and beta, of r squared d theta. Okay, so that's what we're using here. So I'm going to do green minus blue, and these are my bounds. And that's really it. So we're going to do 1/2 of pi over 6 to 5 pi over 6 of my green r value. That's going to be squared. And we're taking away the blue value. Pi over 6 to 5 pi over 6. 2 minus sine theta, and that's all going to be squared theta. Just double checking my work here. Yeah, I'm good. Oops, sorry, it was so complicated. And there you go. That is going to help us find that yellow area. Just setup only, which is super nice. They typically make these setup only. Anyhow. All right, let's get to the next one, which is the one that gets a little bit weird. So we're going to sketch and set up the integral expression to find the common area of the interior now. So this one I'm finding the common area. That's what makes this one a little bit on the weirder side. For r equals 3 cosine theta, and then r equals 1 plus cosine. So again, I'll do green and blue here. So there's green. Let's go ahead and sketch green real quick. Nothing weird here. Just going to go up 3, down 3. So it's cosine, so I start here, work my way down, I work my way up. So I'm going to go over here, 1, 2, 3. Pi over 2, we're at 0. At pi, we're at -3, which is back over here. So it's really the same idea as the sine one. So it's going to look like this. And again, I'm going to draw this like a little bit of a fatter circle than I usually would so that I can try to catch any weird little things. Oh, I should not go outside that. Okay. And now let's do blue. So this is, we're going up 1. So this is 1. So we're going to 2. We're going down to 0. Cosine again. So we're going to do the same type of graph here, except my sinusoidal axis is right here at 1. So I'm going to go here, 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 here. Okay. So at 0, we're at 2. So make sure that I'm just looking at my notes because I know how this is supposed to look. At pi over 2, I'm at 1. Pi, I'm at 0. Pi over 3, I'm at 1 again. That's supposed to be on the outside. That's why I tried to fix that. That blue is on the outside of this green. That's why I was trying to fix it. And then back at 2 pi, we're back out here. So it's going to look a little bit on the weird side here. So if I'm going to go ahead and sketch this right, it's going to, again, I'm going to try to draw this a little bit on the fatter side. So I'm at 2, but I'm decreasing my radius very slowly. And then I'm here. It's going to be cardioid. And I'm here. Again, a little bit on the fat side. It's probably harder to tell down here because I kind of messed up my green, but you'll be able to tell up here what's going on. So I want the common interior. Okay, so the common interior is going to be all of this yellow right here. Okay, so what's important here is we have to find out what my intersections are for this. And that's what makes this problem a little weird. You have to use your brain just a little bit. So here it is right here. So I have this piece right there, intersection right there, and I have that piece right there. Okay? So now when we go to set this up, we have to kind of think this one through a little bit, how we want to set this one up. Obviously, these points are important for us, these brown points. These are the intersections. So let's go ahead and find those intersections real quick. So 3 cosine theta equals 1 plus cosine of theta. I don't know why I drew it in parentheses. Subtract that over. I'm going to get 2 cosine theta equals 1. You're going to get cosine of theta to equal 1/2. And then what does cosine equal 1/2? It equals 1/2 at pi over 3 and 5 pi over 3. But if we're looking at this graph, I don't want to use 5 pi over 3 because I'd be integrating from here all the way around from here. I don't want to do that. So I'd actually be integrating outside of everything. So if I want it to be the inside, I'm going to go from negative pi over 3 all the way to pi over 3. So be careful on that. So I mean, for these guys, take just a little bit of time just to notice. Like, look at the graph. Like, oh, okay, all right. If I go from pi over 3 to 5 pi over 3, I'm integrating everything on the outside. So we're going to have to go from here. So now we have two expressions to set up, and I'll explain why. First one, for the yellow, you notice there's a little yellow sliver here and a little yellow sliver right there. We have to account for those. So what's going to end up happening here is the interior intersection of green and blue. It's not what's in between them. It's not like we're doing this part right here. So it's not green minus blue. It's actually just blue. All we're doing is just integrating blue from here to there. So that's the first part, and I'm going to go ahead and set that one up. So we're going to integrate 1/2 negative pi over 3 to pi over 3 of 1 plus cosine of theta all squared d theta. Okay? That part's not bad. I'm going to need to add something else. Let's talk about these slivers and how we're going to go ahead and find these slivers. So for this sliver right here, I'm actually accounting for the green one. So I'm going to integrate the green from this brown all the way over to these axes, because if you notice this little sliver, what's in between the sliver is just the green and the brown. That's it. So blue isn't not in play for this one. Just like for this first expression, we went from blue to brown. So green's not in play. This one, only green is in play. So we're going to be using this formula right here. So now I'm going from this point right here all the way to here. Okay? Because again, it's a common interior. So I'm going from brown all the way to this axis right here. Okay, so I'm going to have 1/2. Now I'm going to just watch out here. I'm just doing this one sliver. Okay, 1/2 of the integral. The bounds is what's going to be tricky here. So I'm starting from this brown right here going to this axis. So it's going to be from pi over 3 all the way to pi over 2. That's from here to the axis of my green. This is 3 cosine theta being squared d theta. Now that's this little sliver. And now I need to find this little sliver right over here. Do you agree that these areas are the same? So what could you do? You could just multiply this by 2. So that's all you're going to do for that one. And that is our setup. Now, with this times 2 trick here, could I have done that for this guy right here? It totally could have. I could have integrated from 0 to pi over 3 and then just doubled that. Just FYI. You can always set it up if it is symmetric. All right, and that's going to wrap up our video here on day 3 for polar, which is just really area intersections.